Let's go.
So what we need to first take a capture. To do that, first let's open our Wireshark. So Wireshark here and Wireshark. Okay. We capture on our wireless interface. So select that. Okay. So now they open the browser. So we open a Alliance browser. We want a new ignition window, the private window. So let's go there. Then our website, we say ITS. Okay. Open that page for us. Okay, so allow that page to load. Let's go back to our Wireshark capture here. Okay, so we can now stop our capture. The first thing is to apply IP filter. So we say IP.address. But you need to make sure that you know your DNS IP. And from experience, we know already. So I'll just go ahead and do my IP filter to IP.address. Yeah, and that's it. The same network. So we go there. All right. So now after having this capture, we're looking at the first TCP connection, and that is TCP protocol. You could see that in this case, we have a three-way handshake happening. Now, if you go down, you go to the TCP segment windows, you see that in our first we send now. Well, take note that this is the actual. If we have it in brackets like this, is just what Wireshark is telling us, and this is the actual data that we are receiving from our packet anyway. So first of all, in our connection oriented, we have a three-way handshake. In the first packet, we send a sequence number of 0. We get an acknowledgement of 1, which will be seen here. So here we have our acknowledgement of 1, and this packet to receive its acknowledgement being 1 of the packet. So our three-way handshake is established. Now, what you need to know is that in any case, we have what we call the advertisement and then the calculator window, which is actual window size. They help us to determine how the data is being transferred or received at a point in time. However, we see nothing here in our TCP segment. You can find that if you select 1, the TCP segment length is 0, which means that there's no data. So this is how TCP help us to establish a connection between the client and the server. Now, first, let's go to our traffic. In our first session request, we have what we call the client hello. Now, in the client hello, we can okay, so
it's TLS, not TCP.
Yeah, so let's go to our TLS request, and then we have this the TLS hello message. So what do we have in there? Let's go to the hello message handshake protocol. So the first thing we know that we have the TLS version here. We also have okay, good. So the handshake type, good. So the handshake type, we have what we call the selected side, the cipher tube, and if you look at it, we have a number of them. Okay, this number is what we call the curve type that we use. Now these are what the client supports. Okay, so these clients make a request saying hello, and this is the selected cipher suite, the list of cipher suite that it supports. Now what happens if we continue? You see that the server also return with it message. Now in the server hello message, we have okay, what we selected. So this is the server hello. We have the session ID and then random number that you used to generate the session key. And this is the cipher suite, which is TLS Diffie-Hellman curve, and that's what it is selected. So definitely, this is the curve type that has been chosen by the server side, and that is what it is going to use for the key exchange actually. So if you come to then you see client key exchange with change cipher spec. Okay, so looking at this data, you have the uses the Diffie-Hellman algorithm for exchange the key between the two, and then yeah, and that is a secured encrypted communication handshake for key exchange. Now this is the actual data that we have in this key exchange, and you could see clearly that it is encrypted. So if you come here, you see, well, this data is encrypted and you cannot see what is inside the data. and that's we see that. So okay, we select this, select that, so good. And okay, so this is application data as well. So these data is just one data. However, they are being categorized because they happen at a different times, and so you will have multiple data, and based on their acknowledgement, that's what we see over here. Okay, so I think our next action is to be able to decrypt this data. Now take note, the actual data we have here is encrypted. So to decrypt this, what do we do in Wireshark? First of all, we need to create what we call our SSL key log file, and we do that by going to our PC. We go to what we call the environmental variable. So you can go to your PC or Windows, you do this. If it's Mac, you can use the export command. You do XSL export key log file. So here we go to your properties here. Now we go to advanced settings, go to environmental. So we are setting a new environmental variable for our SSL key log file, and we come here, we click on new. You put the new file there, the name is your SS in caps. This name should be the same as this, other than that it wouldn't work for you. So SSL, and it's SSL because initially it's SSL. It's SSL that was updated to TLS. So in the naming convention, it's still SSL. Take note. So we have SSL key log file, and you save it as such, and you can you choose the destination of where this is gonna be. Okay, so we've created an existing file here, and that's what we choose already. So let's just choose this, and it's already there. So we choose this, so we don't need to do this again. We have it already covered. Okay, go okay, and that's done. So we want to use this to filter our packets. We now come to Wireshark here. We go to edit preferences. Then we come to RSA. We select our TLS protocol over here. Let's just scroll down quickly. Okay, TLS. Now we select the file, SSL key log file that is here. So go to this PC, users, KKB, and this is where we saved it to. Keylog, and we save that here. We open it, so we apply it here. Okay, so you see that. Let's see what happened. Okay, good. So you see that at the end of the day, we have this data. You see all the TLS sessions have been decrypted for us, And also one thing that confirms us that you see that at the final instance of communication, you see finished, and you see this finished on the client side, and you see another finished on the server side as well. Now, where is our data? You could see clearly the data that we wanted to decrypt is here. You could see what we call the data text XML. So you just right click on this data to see the actual content. You come to follow and you go to TLS stream. Now in TLS stream, you see the actual data that we decrypted, and that ends that part for us. Now let's consider the data that we've actually decrypted. What can you see? So you could see that the data we have TCP protocol, we have HTTP 2. HTTP 2 just means HTTP version 2. Now this is a protocol that allows us to retrieve data from based on URL from a particular site or any source, Now version 2 allows us to create one TCP session, and on just that session we are able to retrieve and send data at the same time, multiple data at the same time. However, if it was version 1, then we will have to create a new TCP socket. Okay, so and that's the difference. We can take note of that. Finally, we realize that to close a session,
remove the preference you need to.
Yeah, we need to let's see our actual data here. Let's see. Go back to our selection process. Let's see IP. Okay, let's go back here. Okay, now let's go down.
Remove the file, keylog file.
Okay, so we should be able to see our final acknowledgement. I think the data didn't download enough. Anyway, but that should be here. What happens actually is that in that you see your fin acknowledgement. Let's continue with the capture and let's see that again. Hold on.
I'm telling that if you remove the file, the keylog file.
So let me just close this session so that I can easily see that. Okay, so sorry, let me just create the session. You will see, you want to see the final part of it, so let's just do the website again. Right, yes, okay, so just open it for us. Okay, I'll be doing a capture again.
See the same thing
Okay,
because
so
you need to remove the keylog file.
and now we need to close this page so that we can capture the end of the session. So closing it. Now let's see. Yeah, we have our finished session. So you need to understand that it is the closing that will give you this. So when we're closing it, and this will happen. So when we're closing, the client will send a request to a finished request to the server, who says that, oh, I've finished. And the server, okay, oh, good, acknowledges in this packet. And he also sent a finished message in here, and the client also acknowledges in this last packet. You know, and that ends our project A. You can go and sleep. That ends it. I think I can end this now.